about basically about tyre modelling, but that sort of undersells it. So we've been trying to think of what to call the course, and we came up with tyre characterization for whole vehicle simulation, and then I've tried a few other titles since, but it's basically about tyres, how tyres work, how you have to test tyres if you want to model them, and then eventually about tyre modelling as well. And then the bonus of the course that we're planning in September is that we are holding it at ZF Test Systems, which is why we've got Michael Müller from ZF here as well. And Damien and I will be running this course there for some people from ZF, but also for anyone else who would like to join us. The course has already run 3 times when I've delivered it in conjunction with Mike Blundell, who's kindly also joined us this afternoon, but who can't make it when we go to Germany in September. But if anyone's got any questions for him, then we're lucky to have him as well. Before I go any further, just reminding people that I am recording this session so that I can put it on YouTube. If you're not happy with that, then please leave the meeting. But by joining us, you agree to that, basically. If you haven't already, please mute your microphones. Do with your cameras what you like, but just remember that we are recording. And yeah, the main purpose is to give you a flavour of a bit of a taster, maybe whet your appetite for the course that we are running in September, as already mentioned. And yeah, it is now nearly 1:05, and we were due to start at 1, so I'm going to go into the actual slide pack. So that's the title slide. I've already explained about that. We're sort of experimenting a little bit with the title of the course. So I won't dwell on that. So I'm now just going to introduce myself, and then Damien, co-presenter for September, will introduce himself. Michael will introduce himself and ZF, and then we'll go to what the course is about, and then a few of the basics about tyres and tyre testing and tyre modelling. Again, just give you a flavour of what we're doing and why we're doing it. And then, yeah, we'll have some time for questions and answers at the end. So I am originally from the Netherlands, from Holland. I grew up there. I went to university in Delft. I studied with Professor Pacheco, which if you know much about tyre modelling, you will have heard of. I didn't quite know how famous he was becoming when I was there. It was around about the time that the Magic Formula model was conceived. But I joined Jaguar Land Rover and didn't do anything with tyres for about 20 years or so. But I did lots of other stuff, some of which is on the screen there. And then getting on now for more than 13 years ago, I became a technical specialist for objective tyre rig testing and CAE. But I finished at the end of October. I took voluntary redundancy and have since set up JP76 Solutions and doing various things, including having developed a training course on tyres, delivering that in conjunction with Mike and now also Damien. I'm also now part-time, few hours a week, employed by a German company, which there's a few slides about, but they do tyre testing and tyre modelling, and I do some freelance work, some consultancy for them. So I'll now hand over to Damien to introduce himself. You're on mute, Damien.
Oh, there we go. The old "your microphone's on mute" trick. I'd just like to, add a bit of comedy. I always start when I introduce myself by saying I'm even older than I look. So I've been around for a long while and done all sorts of stuff. The start of my career was very analytical, and sort of midway through my career, I became quite practical as well. There's always been a flavour of vehicle dynamics about it, and I say to people that I look at everything from 2 to 10 wheels. So I've never done anything with unicycles, and I've never done anything with very big articulated commercial vehicles. I've done rigid commercial vehicles, which always seems like an ironic title given how flexible they are, but nevertheless. But also quite a lot of work with motorcycles and a little bit with tracked vehicles as well. And I the good fortune to meet Mike Blundell quite early in my career, and so we worked together on 2 editions of the multi-body systems approach for vehicle dynamics, and there is a 3rd one in the works, but I haven't got any. I wouldn't like to commit to a date for that. So that's me. I won't dwell on anything particularly there.
And you worked for a fair bit on tyres as well, and you even developed your own tyre model.
That is true. Yes, I got so frustrated with the Fiala tyre, the model that was included by default with Adams, that I wrote my own so that it had some camber sensitivity, so that I could with motorcycle models in my own time. That was what drove that. It's a very low factor model. In the early video game days, it was very helpful because the computational budget was very low, and so it allowed them to stay real time. But these days, the computing budget is approximately infinite, so there's no real kind of drive for that kind of model anymore. But it was a good learning exercise to make me think about comprehensive slip and long periods of sustained slip, like you see with rally cars. I did find when I started working with rally cars that the sort of conventional magic formula point follower was not very numerically robust if you held it in deep slip for a long time, as rally drivers tended to do. And so my model was quite a nice fallback that meant I could do all sorts of limit scenarios quite well. So you can see that there's 2 of the little videos at the top. One is a car that's drifting. That's with a driver model that I wrote. And the other is a motorcycle that's doing all sorts of interesting things, including drifting. And both of those are using my tyre model as well as my driver model. Anyway, that's enough about me.
No, well, fantastic. Thank you for explaining that. I think quite relevant to what we're talking about this afternoon. Over to you then, Michael.
Okay, so thank you, Jan. My name is Michael Müller, working at ZF Test Systems as a responsible sales manager for the tire R&D testing machines. So you can see it a little bit in the background. It's flipped somehow. I couldn't manage to do it, but now you can see it on that side. So, for example, we have a flat belt testing machine, we have a high-speed uniformity testing machine, able to do obstacle tests, and then on the lower part you can see a treadwear tester. So various different types of testing machines, acoustic measurement machines, but other tailor-made solutions as well. We're producing tire testing equipment since 37 years already. So it has improved a lot. During all of those years, we continuously have tried to dive into new kind of technologies. And I would say in some segments, we are now kind of definitely like technology leader. And we have the approach to be there as a technology leader in all kind of segments. So you can see a few, let's say, numbers and explanations about our company itself. Let's say in general, I guess you know ZF more like a company which is producing transmissions, axle systems, and so on. So ZF Test Systems is indeed kind of a company in the big group, in the big ZF group. But already we do have more than 500 employees, more than 200 million of sales revenue. So quite significant number already. So we are growing and growing and have a global approach as well. And I would say that's basically everything about us.
Yeah.
Thank you.
The reason that I sort of got in contact with yourself was that my interest was piqued by the Roadbelt 5, the ZF flat track type device that's quite interesting and which we will be working with if and when people attend the course. Thank you. So I'm now going to explain a little bit about the course. I've already mentioned that we've run it before. We've had 29 students, both just individuals and then a couple of companies that we run the course for. So we have a proven track record now. Done it 3 times so far, but this time it's going to be spread over a few days and it's going to be done in Germany, a lovely part of Germany, Lower Bavaria, nearly Austria. And by spreading it over 3 days, 2 nights, we're allowing people to travel in on the morning of day one, meet us for lunch, and then we kick off with the first 2 sessions. So that they will explain a little bit about why do you want to do simulation, and how do you do vehicle development through simulation and CAE and all those good things. Then we'll do the introduction to the vehicle dynamics and the role of tyres, which Mike has done in the past and Damien will do this time. And then we're going to day 2, so that's a full day at the ZF test facility, ZF test development facilities. We'll in the morning do another couple of the standard sessions. So I'll do a session on tyre development, and then the most tricky session probably is one about tyre forces and moments and the fundamentals of friction, which Damien will kindly take care of. And then we'll have lunch, and then we're going to see the various test rigs, tyre test rigs, and possibly also other test rigs, including the RB5, which there's a picture of on the screen. So we'll have our plenty of time to go and see what ZF work on, and then after we've done that, we'll actually do some hands-on looking at tyre models, metric formula tyre models, that is, using the Optimum Tyre 2 software, to which you get 2 weeks free access to. So you can do some coursework that we'll be able to give you, and on this afternoon you'll be able to look at some metric formula models, and we will get some data from the actual RB5 and try and use that to create some metric formula models. So the whole process of parameter identification we will go through. That's day 2, and then day 3 is the final day. It's really only a morning where we'll finish off with tyre rig testing, because the state of the art still is that you need to do an awful lot of tyre testing to get data to create models from. So we'll explain everything about that, and then we'll finish off with a session on tyre modelling. What tyre models would you use for whole vehicle dynamic simulation, and the pros and cons, and all those good things. And then we'll wrap up with lunch, questions. Of course, throughout the whole course, there will be plenty of time for questions and discussions and answers. But we'll do it for the final time at the end of this morning, have lunch, and then people again will have the afternoon, evening if needed, to travel back to where they've come from. Throughout the 3 days, refreshments, snacks and lunch will be provided, courtesy of ZF, and basically included in the course fees. So I'm now going to go into a little bit of just a really, 3-4 slides, give you a taste of the content of the course. So why would you want to do virtual development or computer-aided engineering or CAE or simulations, or all those other ways that we refer to, things that people do, trying to predict how cars will behave, and trying to develop systems, scale components, all those good things. And it's all about basically, using a computer to try and replicate what happens in the physical world. Digital twin gets mentioned a lot, so that is basically trying to get a correlation between a physical property and simulation, so that you can enhance your model by physical data, and you can enhance your physical development with simulation results, and vice versa. So I need to move to the next slide. But all these simulations tend to involve the whole vehicle, all the components on the vehicle, and that also include, of course, the tires. Simulations, there are lots of benefits from doing simulations. They tend to be cheaper than physical tests. You can make easy changes, quick changes. You don't have to go all over the world and spend lots of money traveling and waste lots of time on planes, shipping prototype vehicles all over, and lose access to them for days, if not weeks, all those things. And then also simulations nearly always will give you the same result if you give it the same input conditions. So very good repeatability and reproducibility. Unlike physical tests, where you tend to be at the mercy of the weather, other users, and lots of different factors that will affect your physical test results. But tyres play a major role in all this, in vehicle dynamics, and how they behave in both the horizontal plane and the vertical plane. So if you want to do simulations of whole vehicle behavior, you're going to need tyre models, and that's really what this course tries to build up to. Lots of different areas in the company will need tyre models to do whatever all these different departments in the team, in the company will do. So it can be handling, steering, braking, durability, loads, and of course, simply the development of the actual wheels and tires as well. Oops. So tires are very interesting components, and that, putting it politely. They are also a little bit of a pain in the proverbial, as I sometimes say, because they are very, very complicated components to make, and the whole process involves lots of different ingredients, shall I say, including natural rubber, which by virtue of being natural, of course, can be a little bit inconsistent over time. Then there's a lovely video there. I'm not going to play it now, but please click on that when you get a chance and watch how a tire gets made. But it's a very complicated process. Lots of different components go into it, and then eventually the tire actually gets kind of put in a mold and gets baked effectively. So even if you knew all the properties of the materials that you're putting into the tire, how you know how those properties change with being in a mold and being cooked and put under pressure, heaven only knows. So yeah, very complicated process making tires, and therefore very difficult component to predict what it's going to do, to model. Again, here's a slide here. I'm not going to dwell on it, I'm not going to go through it, but listing all the different components and parts of a tire. A tire transmits all the forces and moments. It's the only contact between the vehicle and the road, if everything goes well, if you're just driving around normally. And it transmits those forces and moments by the virtue of friction. And there's different components of friction on this slide. There's 4 listed. The first 2 are sort of the major ones. The viscous ones only comes into play if the surface is wet or covered in snow or other such kinds of contamination. The abrasion one is a relatively small factor. If you talk to experts on friction, there's actually a lot more friction factors, but they all get sort of in diminishing importance. But the mu, the friction coefficient that you get from a tire and a road surface, is dependent on the combination of the two. There is not one level of friction for a particular road, one level of friction for a particular tire. It's all about the combination, and 2 different tires on the same surface will likely to give you different mu, and again the same tire on different surfaces will give you different mu. It's about the combination of the two. That's quite important to bear in mind. This is another slide just to give you a flavour. I'm not going to dwell on it, but it gives you an impression here of the different terminologies that are used when we're talking about tyres and tyre forces and moments. The z-axis is normally in the vertical plane, the y-axis normally in the lateral plane, and the x-axis in the longitudinal forward and aft plane. And then there's different moments. You can see the names on there. And then a tyre might have some angle relative to the road. We call that camber in the vertical plane, or inclination angle, IA, often appreciated. And tyres, if they don't go in a straight line, tend to have a slip angle. That just means that the tyre is not quite going in the direction that the rest of the car is going. No grip without slip. So in order to generate forces, tyre needs to slip a little bit. So there's longitudinal slip ratio definition on the screen there, and then there's also a slip angle for again there's a definition on the screen there for how that's defined. Another slide from the forces and moment presentation, session 4 on the course, or 5 as it will be in September. Again, we'll have to spend quite a lot of time to go through this, but the important thing to remember is that or to consider is that you can replicate and try and model tire behavior by using the principle of bristles on a disc, basically, and that's called a tire brush model. But there will be more about this on the training course, about how the forces but in the contact patch are distributed, how they build up, where they slip, and when, and also very important to factor is this effective radius and other radius definitions that we will go into on the course as well. But as already mentioned earlier, if you want to create tire models, you most likely going to need test data, and there are different ways of acquiring test data. If you have really good knowledge of what's inside a tire, i.e. you're most likely a tire manufacturer, then you could use virtual tests. You could do finite element modeling and try and do the kind of tests that there are pictures of on the screen here virtually in FE. But more likely you'll end up doing tests, again, such as on the screen there, either on a drum or a flat track, or on a whole vehicle. In this case, there's a picture there of the Jaguar Land Rover V-Bot, the vehicle-based objective tire testing rig. But it's, yeah, don't look at that as a car, look at it as a test rig. And again, on the course, we will talk a little bit more about that, because that's a project that I led the development of in my time in Jaguar Land Rover Tire CAE team. This slide tries to depict what sort of different tire models you might use for what kind of tire, what kind of whole vehicle simulation maneuvers or test scenarios, or whatever you want to call them. You're not going to dwell on them too much, but for empirical models, think Magic Formula or the Harty model as just described, and models like that. Physical models, think of CD tire, F tire, to an extent also Swift, extension to Magic Formula, and then FE models, so finite element models, which you really in the tire manufacturer realm. There is some possibilities, and I know some people who create finite element models from stripping a tire down and trying to work out what the components are, but it's really, really complicated and really, really time consuming, so that's not normally done. Yeah, and then we get to what we are offering. So if you like what you've seen and would like to learn a lot more in a lot more detail over time, and the chance to visit the ZF test facilities, you can join us in September. The course is in person only. It will be delivered by myself and Damien. It will be on Tuesday the 1st of September running to Thursday of the same week at Passau in Germany. We are offering this for £999 or €1,149. If you pay that by the end of July, after that the price will go up, I'm afraid. And yeah, if you want to register interest, you can do that by clicking on the QR code there or on the link on this slide. And this is the summary of what I've just talked about. So yeah, it's a training course for automotive engineers, researchers, people in academia, anyone who wants to know a little bit more about how tires work, how they affect vehicle dynamics, what's important in how they work, and what's important in how to test them and how to model them. And yeah, like I said, we've had 29 happy customers so far already, and we hope to get a lot more in September. And I will now open the floor to questions, and we will try and answer those between Damien, Michael, possibly Mike, and myself. Thank you. Anyone, please don't hesitate. K Maths has lit up, but I can't hear anything. Carl Becker is now lit up.
Yes, Carl Becker from University of Pretoria.
Hi.
Have you guys had any experience with agricultural tires? Because those large lugs cause havoc.
Yeah, I personally don't have any experience with that. We will touch on a little bit about soft soil modelling on the course, but just 1 or 2 slides and just explaining that it's very complicated. But Damien, Mike?
Yeah, the closest I've come is World Rally, which is still not really the same, but it is a deformable surface problem. But the agricultural tyres in particular, they've got these big. If they're on a tank track, they'd be called grousers, but I don't know, lugs, I guess you call them. And it's really about kind of mechanically engaging with the shear failure of the soil. It's kind of, I guess it depends what your question is, but we can certainly put you in touch with, there's some guys at Cranfield who do a lot of drawbar testing. You may already know them. And they're probably more expert than we are in terms of agricultural stuff and deformable terrain in particular.
Yes, the big thing now is these big tractors are being used on asphalt roads because the farms are so large. They drive them on asphalt roads from one farm to another.
Yeah.
And they would like to be traveling at 60 kilometers an hour with those big tires.
Yeah.
And we've got a test rig that we can test those up to 5 metric tons vertical load. Dynamically and statically, we can go up to 25 metric tons.
I can share with you the capabilities of the rigs at FKA in Aachen, Germany, because they do have some experience, but you probably end up doing drum testing rather than flat track testing with tyres of the sort of sizes we're talking about there. But you can then enhance the models you get using some of the stiffness tests and things like that. There's some expertise that I can give you a taste for, and then if you're interested in more, I can put you in touch with the people at FKA.
Can I just ask, Carl, are you hoping to do computer simulations, sort of multi-body simulations of the vehicle in both environments?
Yes, in general, the clients are interested in that, but they don't have tyre data. That's the biggest thing.
Yeah.
But we've got the capability to test those tyres, but the radial run out and the noise created by the lugs are quite interesting.
Yeah, I bet.
Yeah, I think. I mean, the only thing I can share with you, it's different, but it is a dual application like that. I've just finished some work with a company in Switzerland that make road rail vehicles. So these are heavy vehicles like construction equipment vehicles, diggers and things like that, used for construction work on the rail system in the Swiss Alps. And they have to drive on the rails using their tyres, and they have to drive on the roads between sites where they access the rail system as well. Yeah. So we actually we actually built a rig in Switzerland just to test the tyres on the rail, and we built a simple tyre model for it operating on the rails. So I'd be quite interested in the sort of how you model it if you can get the data for both environments.
Yes. No,
the other thing that it occurs to me is that Jan might be able to give you some advice on setting up something equivalent to the VBOT vehicle that they've done, but with an agricultural vehicle, so that you can understand. But you by measuring what the vehicle's doing, you can infer what the tyres are doing, and that's quite a fairly well developed method. It's been in use for a while. The only problem is, of course, if your tyres don't fit this particular vehicle, then you need to convert another vehicle, and before you know it, you've got a whole library of vehicles, which starts to get a bit irritating.
Yeah, luckily we've built a trailer that we can do all of this.
Oh, nice. Okay. The trailer's an even better solution. Yeah.
Up to 2 meter diameter tyres easily. So we've got some interesting data.
I have also had some correspondence just this week, actually, with a chap at Volvo in Sweden, ex-Delft colleague, and he's basically simplified the metric fauna model a little bit to make it more easy to get the parameters for big agricultural tyres as well. So it might be worth tying up with him. I can put you in touch with him.
Yeah, that'll be awesome.
No worries.
I'm not sure if I'll be able to attend your course. I would really like to, but at this stage, I'm not sure.
Yeah, I appreciate that. You have to come a long way, I suppose. But
I need
you'd be very welcome if you can swing it.
I'll definitely try.
Excellent. Thank you. Anyone else got any questions? Oh, we've still got a guest arriving. Blimey.
Damn. They're probably on daylight savings.
Anyone else got a question? I get the feeling someone's trying to talk. Maybe not. Greg, I think you just joined. You've missed most of the session, but it is being recorded, so you can watch it back on YouTube, or you can join the later session tonight, this afternoon. If there's really no other questions, then I guess we better close. Thank you everyone for attending. You can always drop us a note if you do think of anything later on, or you want to know more about the course. But the process is that, yeah, on the screen here is the QR code and the web link. I've also posted it already on LinkedIn loads of times, and you can register your interest in the course on there, and then I'll send you the brochure and the registration form so that you can sign up, hopefully. Okay. Going once, going twice. Any last minute questions? No? Okay. I declare this session finished. Thank you, Damien, Mike, everyone else. I might see some of you later, and otherwise perhaps in Passau.